Recording started. Over to you.
Okay, thanks so much. Okay, so again, my apologies, and I continue to work out the kinks on getting more attendance for the Seapower Conversations. The Seapower Conversations that we've had thus far have largely been focused on lessons learned from Ukraine and the Russian invasion. However, we did have the Seapower Conversation related to questioning the carrier, and then nominally the Hellfire Seapower Station also was more related about the Western Pacific. So welcome everybody to our Seapower Conversation today. It's going to be about intelligence and imagery. We have a guest speaker, Lieutenant Colonel retired. Dip Schnick is the man on the screen there, and I'm going to be switching over to his slides here in just 1 second. Dip, do you want to give any further information about yourself real quick?
Sure. Thank you, Rex and Sheila and Randy for the introduction and invitation. Really excited to be able to speak with you today. I'm a retired Marine, as Rex said. So as a backseater in Hornets out of Beaufort for 2 tours. And as many of you know, you don't get cool call signs like Thor or Viper in the Naval Service. And so got a chance to do a couple tours to Iraq, a couple tours to Afghanistan, a couple tours to Japan, did a battalion and regimental air officer tour, and stood up the UAS division at VMX, went through WTI as a student, and then finished up my last 3 years in the Pentagon doing great power competition. So very, very interesting access to red and blue capabilities. Out of that, I did a quick stint at the Strategic Capabilities Office as a SATA before I got picked up by Microsoft. Worked there for about 2.5 years and now joined Synthetaic about 6 months ago. So I come at it from, a little bit of that perspective when I look at the usage of these tools to be able to get after great power competition and how you would leverage them. So just a little bit about me. Thank you for allowing me to introduce myself, Rex. So I'm the federal account executive at Synthetaic, and so we'll go through. I'm okay with questions in the middle of the brief, so don't feel like you've got to hold all questions to the end. I don't plan on spending all day on slides. The definition of a brief is by nature a short amount of time, and I think the demo really gets after some of the use cases for our solution across all 7 warfighting functions. So with that, Rex, next slide. So as many of you know, there's a lot of data that's produced every day. Every day the world produces 100 terabytes of satellite images, 5 billion photographs, and about 1 million hours of footage. And we're starting to see some interesting capabilities where we're maxing out on data center usage. And so they're going to have to kind of think how they redo that and be able to get more data into a data center at a lower cost per data point, and then also lower energy costs as we look at global warming and items like that. Next slide. And so what if all that data was instantly searchable, or what if your data was instantly searchable? What new questions could you be asking and could you be answering? So our CEO and founder, Corey, is a very interesting background, National Geographic Explorer of the Year in 2021. He's been on all 7 continents. He's LiDAR'd Mount Everest. He's actually been down to the Titanic 3 times. He went down to the Titanic when James Cameron was filming the movie. He's been down there with Bob Ballard, and then he's also been down another time. And so he's got this really, really interesting background shot at in helicopters by poachers in Africa trying to do animal surveys. And what he found was if you take a pre-trained model or a human data labeled model and you try to move it from the savanna to the desert or the desert to the jungle, it typically doesn't translate very, very well. It hallucinates, it fails. And so him and our CTO said, well, is there a way to come at this from a different angle? Like, what if we could just start from a different way of doing business? And having been in the Pentagon during 2017 to 2020, having worked with the JAIC, having been a part of the AI task force with the Marine Corps as we wrote the strategy and as the addendum to the Department of Defense strategy, I saw the machinations of Drew Kukor and Jack Shanahan trying to find people to label data and deploy those models. And so next slide. that's where our solution comes in, RAIC. And so what RAIC does is it makes your visual data instantly searchable. Instead of having years of person hours to go through and build a model, you can start instantly once your data has been ingested. We're data agnostic, so you can find anything in your unlabeled data, and it's a force multiplier. As a retired Marine, I call it data science for the deck plate. You don't need to be a data scientist to leverage our solution to go against your data. And there's this really, really interesting human-machine teaming, human-AI collaboration solution that comes with our capability, which I'll, when I get to the demo, we'll do, which allows the artificial intelligence to do what that does best in collaboration with what humans do best. Next slide. As I mentioned, we're data agnostic, so any image, any use case. So we are able to pull down geospatial data, satellite EO, red, green, blue, synthetic aperture radar, infrared from satellites. We can do video, MP4, and so security cameras, cell phone cameras, body cameras, perimeter security, facility, you name it, UASs, we can ingest the data and go against it. And we can do JPEG and PNG. And it can be orthorectified. We can do midwave AR and thermal. And so a really interesting way to get against your data sources, depending on what you've got available to you and what answers you're trying to get. Next slide. So another interesting point about the solution is it allows you to do a number of different items, a number of different things inside of one platform, right? You can do data labeling and classification. Our solution does change detection and object detection. You can do anomaly detection, and it also allows you to do large area classification. Next slide. So you may be familiar with our company. It's pronounced Synthetaic, not Synthetaic, although that's what I thought it was when I first learned about the company and started to investigate it. So about a year ago, Corey, our founder and CEO, and Bill, the director of federal partnerships, were at FedGIS in DC, and they both got COVID. So they're in quarantine at their house, and the balloon got shot down off the coast of South Carolina. And so Corey said, do you think we can find the balloon inside of the PlanetScope imagery? And Bill's like, I bet we can. Let's give it a try. So the two of them sat down, and with one seed image, so our solution is a one-shot, few-shot search capability. Again, not pre-trained model, not human data label model. You do need to start with a seed image, but once you start with that seed image, it'll bring you back the results, and you'll see that in the demo later. So literally, Corey, our CEO, took a Surface tablet with a Surface tablet pen and said, I bet the balloon in red, green, blue looks like a circle from from PlanetScope data overhead. And that was the seed image. So no pre-trained AI model or labeled data. Searched the entire equivalent landmass of the Earth twice with PlanetScope imagery, 3-meter daily imagery. And the first detection happened within 2 minutes. So Corey said, well, is there any other balloons airborne at this point in time? And so we were able to find another balloon that had floated over Central and South America at the same time. And then because we have a planet partnership, we were able to go through and find some historic data, do forensics analysis, and we found another balloon that had been floated over Japan and another one that had been floated over Taiwan in the archive data in 2021. So a really interesting opportunity to get after your data. You don't have to just have today's data. If you want to track some stuff, you can go back. Another item that's interesting to note is when we did this, we literally went from the border of Mongolia and China all the way down to the Hainan Island, and then the entire mass of China to search to see where that launch point might have been. So that's where you come in with the equivalent of the landmass of the Earth searched twice. And so part of that we kept getting, because RAIC brings you back about 1,024 images for you to interact with, and then select the ones you're interested in. You can exclude some images, include images. And we kept finding aerostats. And so we went back historically to 2019, dumped that into a Power BI dashboard. And we saw the increase in Chinese aerostat program usage over those 4 years. At the same time, we were looking for nuclear missile silos in the planet imagery, which you can find. And if you look at the data, there's a really interesting use case where there's aerostats in close proximity to those fielded nuclear missile silos. So now that gives you an opportunity, all with unclassed data, open source, to swivel chair over to a higher level classification and ask deeper questions of your data, because you get that velocity, speed, and direction to the interaction with your visual data. Next slide. We work with aircraft airborne. This is an example where the satellite imagery was pulling down from Planet when the Blues were flying down off the coast of Pensacola, and we were able to find their formation flying off there. So it's not just finding things on land or on the surface of the sea. We can find things airborne also. Next slide. Rex, did we freeze up for a second?
Right there?
I am. Can you hear me?
Yeah, I can. Can you hear me? Okay, great. So my question was, was this a good learning example just because the Blue Angels are constantly flying over Pensacola, or how would you frame that?
So it's just another example of a use case where if you've got the visual data to go after, you can find things of interest in there. And we're not just limited to things that are on the ground or on the ocean. You can leverage airborne assets also.
Thanks.
You're welcome. Next slide.
Sorry.
Oh, that's fine. Thank you.
There we go.
As I mentioned, you can monitor and track critical changes. So the interface for the user allows you to go into your seed imagery. So if you've collected imagery, you can go inside of it, put a bounding box around something of interest and start searching for it. You can upload an image from your desktop. You can download images from a web search, or you can do a DALL-E generated image where Azure capable commercial software as a service available. And so we've got a DALL-E plugin. So if you're familiar with Sam Altman, OpenAI, Microsoft is leveraging OpenAI to do ChatGPT and Copilot. On the other side is the image generator. So we actually have a plugin that allows you to do image generation. And so this seed image in that lower left-hand corner of the rectangle, that is a DALL-E generated image in floatable dome covering a missile silo in a desert environment from an overhead view. And from that simple seed image generated by DALL-E, we were able to go and find the real images of the nuclear missile silos in China. And unfortunately, due to the tyranny of the size of the PowerPoint, you're not able to see the bar going across to show the change detection and the before and after from them putting in the nuclear missile silos. But we do change detection. We're working on a project right now where we're surveying a large amount of the ocean for a federal customer. And our change detection, there were 3 warships in port. And then the next day, those warships were not in port, and we got a notification that they weren't, and then we were able to go and search and find them where they were at sea. So, interesting use case. Also, from are you trying to track things and keep custody of them? Obviously, as you know, satellite data is dated by the time it makes it from the orbit down to the ground control station and into the cloud for you to be able to go against it. So it's not real time, but it's still an interesting use case that as satellite providers get more fluent in downloading, especially if they're using laser comms, we may get to the point where you can actually hold custody of assets in real time from satellite capabilities. Next slide.
Dip, what's the lag on that?
So a lovely bots one answer. It depends. Right, because it depends on if it's in geo and it's a steady stare and how often the update rate is from the download from that geo perspective. If it's in LEO, it depends also based on what imagery you're looking at. So if you look at Planet, for an example, Planet's LEO satellites are falling constantly, and so they're covering a section of the globe about every hour and a half as the globe turns, and they're falling, and then they've got to download that data. And so that can be somewhere between 24 and 48 hours, depending on where it found the data and then where the download opportunity is from the doves that Planet has available to them. So there isn't a one size fits all on that. Did that answer your question, Rex?
Yeah, thanks. Sheila, you had your hand up?
Yeah, so Dip, can you speak a little bit to the technology under the hood?
Yeah, so our solution generates a vector search space. So what it does is that you take a seed image and upload it, and then it statistically generates a vector search space based on that seed image, a pixelized capability. And then it takes that vector search space and searches through your imagery that you've uploaded or downloaded to find the things that are of insight to you. And then out of that search, you'll get the results back for what it saw in your data. Not everything, but some of the things. And then it allows you to start to build and expand and continue to refine as you either build out a model that you can export to like a computer vision model that's lighter touch. It could be, resident on a ground control station on a smaller group 1, group 2 ES, or you can ingest more data and then run the model against that data the next day, whether it's full motion video, JPEG, PNG, or geospatial. Did that answer your question, Sheila?
Well, yeah, partially. I think it's a deeper conversation because there's many companies that come in and say, hey, guess what? We can find a needle in the haystack. And you have a solution that's got a fair amount of traction so far. So I'm trying to understand the uniqueness here. Just breaking it into a vector space is the first step. What are the false alarms? How do you manage to separate out, all kinds of stuff here and yet win the war? So maybe it's a different conversation we can take on later.
That's a great question. So one of the things, right, is that you're not going to, it depends on where you are in the journey with your data and what you've done with it to build out. So if you're just initially interacting with your data with a couple of seed images, there isn't really an F1 score. You're just starting to go through your imagery and find what's in there that's relevant to you, to which then you could build a RAIC set or a model. And then as you ingest more imagery, you can go ahead and go against that imagery. From a engineering speak, right, and I'm a retired Marine, and for all of you on the call here, you know that that's an acronym, right? Muscles are required, intelligence not expected. So I won't, use big, I can't claim to be the engineering expert on it, but our CTOs basically said, it's an integrated, where we've taken different AI technologies to create a holistic promptable search engine for imagery that generalizes both finding the anomalous objects, but also finding the more common objects. And then you can build, and because we've built that AI human interface through the UI, UX, it allows you to interact with the data in a way that doesn't happen with other vision AI models. And so it makes RAIC intelligible because it's generating that vector search space. It brings things back similar to what that seed image was, and you can get an understanding of what RAIC is thinking about when it generates the results from that search. And then we don't compete at AI architectures. We compete with how AI architectures are used and how their technologies are integrated. So our algorithms, are typically high power compute, although we do have edge device capabilities for full motion video. And our algorithms are proprietary. So it's not algorithm as it's a pre-trained model. It's not an algorithm as a human data labeled model. It's an algorithm as it's a, generates that promptable search engine, which then allows you to build out after that. Did that help refine it a little bit?
Yeah, how long does it take you to build a model?
Depends on how talented you are, but when I do the demo, I'll show you can build out a model in about 2 to 5 minutes.
Okay, thanks.
Yeah, you're welcome. Any other questions? Excellent. Next slide, please. So it works even in harsh environments. This is an example where we were at Trident Spectre, and there was a semi-submersible that was supporting Trident Spectre, which is naval special warfare exercise opportunity to interact with industry. And so this is a Dolly generated image, Coast Guard small craft. That was the seed image that we used. We downloaded the video from the Ocean Arrow semi-submersible. And so it's bouncing around due to the waves. There's spray coming up on the camera, and we're still able to find the guard craft for the Navy inside of the the imagery. Our solution, next slide, puts really tight bounding boxes around things. We are also able to do synthetic aperture radar, as I mentioned before. So this is an example where we worked with Capella Space Data to find the Tu-160s at Ingalls Air Force Base. And so from an unclassed, if you look at the EOCL data, right, that's Black Sky, Maxar, Planet, the government already gets that data for free, right? The government pays for it, so the Department of Defense can leverage it, the IC can leverage it. We can process any of those capabilities. Next slide. So one of the items too, before I get to the RAIC, is you don't have to use our solution from left to right. You could use our solution as a label, or you could drop that in as part of your workflow. So when we did our SBIR phase 1 with AFWorks, with the Kelly Johnson Innovation Center, with the Michigan Air National Guard, they did a human data label, versus RAIC, and we were 21 times faster than human data labeling. So quite the velocity there. And then the next thing that was really, really of interest is if you used our labels, and you'll see when I do the demo, the boxes are really tight. If you use our labels, the model F1 score that was built out of those compared to the human data labeled built models was about 9.2 percentage points better. So if you've already spent time with data scientists, you've already got a human data labeled model, and you don't want to lose all that work, our workflow drops right into that labeling portion. And so you can really rapidly relabel what you're working on. We're working with a defense industrial prime who has EOIR balls on aircraft, and their customers saying, hey, like when we move from, as I mentioned, a desert environment to a jungle environment, or if the adversary changes the capabilities on the battlefield, it takes a really long time for them to update their model that then resides as a computer vision model inside the FLIR ball. And so they're interested in perhaps leveraging us to be a drop-in into that human data labeling where they can more rapidly update the models as part of their workflow. As you know, everybody's seen, right, the QR code on the stop sign. So stop sign, baboon, or the panda baboon, the hallucination that happens. We saw that with the Z's on the side of the Russian vehicles. Because our leveraging our tool capability for labeling isn't bespoke, and because it renders the vector search space holistically, the Z on the side of those vehicles didn't throw off us being able to go through the imagery and find the vehicles that were there in the imagery. Next slide. So just a quick overview of how it works. So you would bring your data. So we're a software as a solution residing in Azure. You bring your data, it gets ingested, and then from that, you can search, categorize, and then build quick models that you can then leverage and save, or you can build deep models, which you can export to a device like a YOLO model or computer vision model that's lighter touch, and that might reside on an edge device or on a UAS ground control station. So as the videos coming in, and I can show an example of that from our SBIR phase 2 with the same organization, the Kelly Johnson Innovation Center. And then the insights can be exported via APIs. So we do for geospatial, we can do GeoTIFFs or GeoJSONs, CSV files. So there's a couple different ways we can export the data in order to get it to wherever it needs to go. Or as I mentioned, you can build your own models and just save them inside of RAIC. And as you ingest more data, you just run that model you built against the new data ingest, and then you can rinse and repeat. Because it's so easy to build a new model, you can burn down what you had and then go back and rebuild a new one. Or, an example in Ukraine, right? It's all the leaves fell off the trees, and it's no snow on the ground, and then there's snow on the ground. Well, now you got to go and rebuild your models. Well, you could easily do that, or take imagery from somewhere else where there was snow on the ground, build your model, and then leverage that. Whether you export it to a UAS to get the bounding boxes around the things you're looking for, or if you use it inherently in RAIC because you're doing higher level results, more COC at the regimental or MEF level. Over. Next slide. So we've got a number of interesting customers between the Air Force and Space Force and NGA, Air National Guard. We're partnered with Booz and Planet. and Microsoft, which is why we reside in Azure. And there's 3 lines of effort. There's the DoD Fed IC, we've got a commercial line of effort, and then there's an AI for impact line of effort. Next slide. As I mentioned, we were at Trident Spectre last year. We're going again this year. We're the highest rated software capability last year. And so really, really solid results from NSW and NGA, which has kept interest in our solution. Next slide. And then to get started, we're a software as a service license, so you could purchase and ingest data. We're how much data, how many people, and how long do you want to be purchasing a capability. We can do just the insights. We've got 2 customers right now that are asking us to rake the data that's coming down from the OSINT satellites, as an example. And so in our imagery analysts, they're not geospatially trained, former NRO, former NGA analysts. They are literally college students who thought this was a really interesting company to work at and applied and started. And we're doing one of the projects right now. We're ingesting about 2 terabytes of data a day, and they're going after that, finding the changes and then making results and then exporting those to the customer. And then we could also do pre-built models with a custom build. So there's a couple different ways to leverage our solution. Next slide. All right. So I'm going to switch to share screen, if that's okay, Rex.
Yeah.
All right. So let me know if you can see my screen. All right. So I must have picked the wrong one. There we go. All right. So does everybody see a large Air France airplane?
Yep, we got it.
Excellent. Thank you. All right. So as I mentioned, we have 3 different ways to interact with your data. You can map data, geospatial, RGB, and SAR. You can do JPEG or PNG images. And for video, MP4 is the version you would upload to be able to start to go against. So we're really good at finding obscure things, as I was mentioning, and you don't need a lot of seed images. So what I'm going to do is, this is Milwaukee. You can draw a bounding box around an area. So you don't have to search all of China. Like if you're only interested in one section, you can search one section of China. So this is Milwaukee. There's a Coast Guard craft here. I'm going to hit search on that, and then RAIC's going to run, and that's going to take about a minute or 2 to run. So while that's happening, I'm going to go to our full motion video. So this is an ingested video. It's about 12.5 minutes. It's from the post exercise out in Hawaii, and this is the Honolulu police training area. And so I'm going to use this Dolly generated steampunk image to do a quick search. And so you're going to see in about 3 to 5 seconds, you're going to get results back that are similar to the seed image. And so again, remember, it generates that vector search space and allows you to interact with the data. And this is a quick search. So there's some things here on our solution that I haven't seen with other technologies. Now, it doesn't mean that they don't exist, but I haven't seen them. So here's the min confidence threshold on the quick search. I can adjust this. So I can make it tighter to where I get less results, or I can open up that and get more results. And so I went from 1 page to 22 pages, and I can now start going through my data, see what's there. I can click on it and see the individual points. Here's where there's some really, really interesting opportunities here. I put on my retired Marine hat. I remember, Intel analysts trying to figure out where things were in the time date stamp and write a report and get that into the system. Or I remember in 2007 when I was in Iraq watching the Lance Corporal come out of the skiff completely white because they just spent 8 hours looking at sensitive site exploitation data, and they just spent that time watching people get their heads cut off and bleed out. Well, you could use a scene image to do content management to look for the things in a quick search to, instead of having to watch that 10-hour video, use that seed image to quickly search through and see if there's anything like that in your imagery, and then write the report because you get the date timestamp. And then when you click on each one of these, you can see where in the image that is located. So a really, really interesting way for a human machine teaming to just initially interact with your imagery. Typically what happens, here we go, perfect, is there's a police officer who comes up when I opened up the aperture for the data. So what you can do now is you can see, all right, I get why the police officer would have been picked up in the frame. The seed image has a uniform. The seed image has got blue in it, what looks like a badge on the seed image. There's also boots, a belt, accoutrements on the belt. So you can see why when you open up the threshold, that this might be one of the images that would come back in that quick search. And again, you can see where that image is in the date timestamp based on the video. So a really interesting use case for interacting with your data. I'm going to do a deep search now on that. And while that's running, this should have completed. So now I uploaded, as I mentioned, that one image of the Coast Guard craft. So what RAIC does when you do the deep search, and we'll see that shortly in the full motion video when we go to that. Now I can start clicking around the tiles. So red is it brings back things that are most similar to the seed image that was uploaded. Purple is least similar, but it's still bringing it back for you to interact with. So I can go in and I can do this tile function. I can see the image of those craft, where they are inside my imagery, just from that one seed image. And then you can go, let's go over, take a look at, some of the purple ones. Well, you can see, there's this interesting, almost rectangular shape. So, and there's, squiggly lines. So you can see why RAIC might have brought these buildings back as images that are similar for you to interact with, right? You're getting an idea of like, okay, it generated the vector search space. It's bringing back results, but I know that those aren't the ones that I'm interested in. I can click in here. All right, still similar, interesting shape. There's a ridge that runs kind of down the middle of that looks very, very similar to a peak to a house. I get why RAIC, brought those back. And then there's other boat images that are here also that you can see. And so that's all just clicking on the surrounding tiles. What you can do then is you can draw a lasso around these in order to see where they are in the imagery and zoom in or zoom out. So now I can see that there's about 16 images that I've selected. One's out over the water. I can zoom in. Is this what I'm looking for? I'm looking for Coast Guard craft. Yep, that's probably a Coast Guard craft, one of their 2-engine ones. All right, what else did we find here? That looks a lot like a tug with some sort of, barge attached to it. Other tugs, but now this gives you the opportunity to interact with the data in a way that you wouldn't have previously if you were doing a pre-trained model or human data label model. And then from this, I could build a new model. I could do, tugboats and Coast Guard craft, and then I could, exclude, the houses, or maybe I don't want the images over here of the boats that are covered. So I could exclude those, and I could run the RAIC image again, and I keep making it smarter and smarter and smarter as I run it. Let's go back to the video one. So as we saw, there was 1,024 images with the satellite one. Here is the results of using the seed image here for the deep search on the video. So what I can do is I can build an exclusion. Let's say I don't want the police officer, so I can create new. I'll call this demo for MPS. And I'm going to call this person with rifle. And what I can do is I can add these to my exclusion. So the next time I run this against the imagery, those don't come back. And now I can go in and start to look at these images. Yep, I can see the person walking around with the rifle in their hands. These look really good. Red again is most similar. Purple is least similar. Yep, I can see the person with the rifle. This is always interesting. These two typically come back. Let's zoom in on the full motion video, and it makes sense why these would come back. About 1/3 of the imagery, 1/4 of the image is legs with uniform and boots, or uniformity in boots. So what I'm going to do now is I'm going to add these images. Person with rifle, and I hit create. And now I've got 992 images that I can start to interact with and build out a model. And you get to choose the images that you want to use. And so Sheila, when you're getting back to how quickly can you do this, we ran the seed image, we got our results in the deep search. I was doing another thing, went back now. I can go ahead and include these. Let's say, lots of people walking around now with those chest purses. So maybe I don't want the strap from behind, so I don't want these. So I can throw these in the trash as I'm going through. And again, as you're interacting with your data, over here on the left-hand side, you're seeing in the date timestamp of where those results are coming back. So really interesting human-machine teaming again, that gives you the results. And then you can just keep doing that. And then you can go through those 992 images and you save that. And then you've built a model, person with rifle. And as you get more video, you can ingest that video and then run that against that. Or you can build a YOLO model, a computer vision model, and export it. So here's an example where we built 4 labeled classes in a day and then exported them to the ground control station of a quadcopter. And so it's hard to see because this is covering it, but it's civilian vehicle, military vehicle, personnel, and military structure. So we built the YOLO model, we exported it, it's on the ground control station, and now this is running, and it's putting the bounding boxes around the vehicles and the personnel. And this is where, okay, let's say it snowed. Well, the next day you can go out, ingest the data, and build out these 4 categories again with the new results of the atmospheric changes. Or you deployed and you're no longer at the beach where it was more deserty, you're now inland where it's more savanna or whatever. You can make the changes you want or you need to in a relatively quick fashion. And then typically what the question that comes up is, okay, that's great. This is pretty wide open. How does it work, in a more contested or congested area? So here's an example where there's people on top of the roofs, and it's pretty often putting the bounding box around the people on the roof. You're going to start to see people moving inside the tree line. And without zooming in, it's going to start to put the bounding boxes around the people inside the tree line. So that's in the shade, it's in the forest. So yep, it's picking the people on top of the building, but it's also picking up some of the people inside the forest. And then if you zoomed in a little bit further, you'd more than likely be able to get better results with that. So that's just an example of hey, I can use RAIC to build a model, ingest the data, or I can use RAIC to build a model and export it to a UAS that's flying around. Or to a EO/IR ball on something. And as I mentioned, the use cases are up to your imagination and what data you've got available to you. We had a Department of Transportation from a state say, hey, we've got roundabouts in our state. We don't know where they're located. We don't know where we'd start to answer that question. And so what we did was we uploaded 3 roundabouts. So as I was mentioning, you can upload a seed image from the web. So we could do giraffe from a web search as an example. Let me pick this one. And now that's going through this 118,287 images while it's looking for the giraffe. So we uploaded the image of the roundabouts, and within 15 minutes, by putting the bounding box around the state, we had identified all 350 roundabouts in the state. How would you even answer that question? Would you hire a company from a consulting perspective to drive all around the country or all around that state to try to find those roundabouts and then do that? And we can geolocate them. So our bounding boxes, you can georectify them. And so we had a list of 350 roundabouts with the lat longs, and we did that in 15 minutes. And so, hey, how many bridges are there across the Danube? And you're a logistician, quickly put a bounding box around the Danube, upload a seed image of a bridge and answer that question. Or, hey, how many railroad sidings are there to load armored vehicles on flatbed train? You could upload a seed image of the side load area and then pull down the satellite image for, let's say, the nation of Germany and do that. We've done some imagery with mid-wave IR, and we were able to find trench lines underneath tree lines in certain countries in Eastern Europe that might be of interest to all of us. So again, use cases are up to your imagination and what data you've got available to you. So Rex, I've been doing a lot of talking. I can't thank everybody enough for the opportunity here. There's probably questions, and you were kind enough not to interrupt. So please interrupt, ask questions, and I'll do my best to answer them.
So I have a follow-up, Dip. This is Sheila. Have you guys approached any robotics firms to work with?
So it's funny you mentioned that. We actually are talking to a SI who does some connectivity between the robots and like a command and control station. And so, yeah, we're looking to see where we might be able to be used for robots, whether it's pulling the image back to the COC and raking it there in a kind of a forensics analysis, or building out the model, exploring that computer vision model, which typically is pretty light touch and low compute, to the edge, like I just demoed from our 4 classes, and then doing that also. So yeah, but we'd love to get introduced to more people.
So because I'm thinking, more like a warehouse application or a logistics application where you could, if you really can provide a model within a couple of minutes to identify a bottle from a dime or something, right?
Yep. No, it's great. Thank you for that.
Yeah.
Yeah, as I'm thinking about this, Dip, one of the students that is in the soft community is working on a pretty neat project, but it's on a different classification level. So we'll maybe be able to get some stibble time and have a conversation.
Yeah, that'd be great. And we've done that too, where we've built low, deployed high. So we're currently in the process of working authorization to operate on IL5, controlling classified information, and always looking for a sponsor for secret or TS to help with that. But yeah, we've done that with a customer where we built the models in commercial and then exported those to a higher level of classification for them to run against data because we don't have an ATO yet at the higher levels.
Yeah. So I'm glad we're recording this so I can share it with some folks that weren't able to make it today and continue to generate different ideas and different utilization for our students and elsewhere.
Excellent. Thank you for Rex. What else? Who else has a question?
Go ahead.
So this is Yukito from Japanese international students. So I'm researching the false targets against SAR imaging radars. So does it have a function to register the false target or adversarial data to identify?
So less false targets and more finding things that, wait, let me rephrase that. If you have examples of false targets and an analyst can see them, RAIC can see them. That's kind of the use case or the need. We had a customer that came to us and we were using 3.7 meter imagery from PlanetScope, and they were disappointed that we couldn't find a manhole size capability inside that 3.7 meter imagery. So we have to be very, very careful to make sure the customer or the end user understands that if an analyst can see it, RAIC can find it also. So theoretically, yes, you could find false results if you had examples of those and you built a RAIC set to go against them.
Yeah, thank you very much.
Back to Sheila's earlier question of, I think anyway, it might be in terms of the human AI teaming, but I think that it would take a skilled analyst to see those people that I've identified in the woods in that particular example that you shared. Is that how that is created, or was that all sensed by AI hunting through those images to find the people in the woods?
Yeah, that's a great question. So the imagery was not built with people in the woods. It was literally built with personnel. So we, in an open area, picked out and then put, leverage RAIC to put bounding boxes around personnel, and then built out a YOLO model or a computer vision model that was exported to the ground control station along with those other vehicles. And so even though it wasn't trained on people in the woods, it was trained on personnel, and it picked up those personnel in the woods without having to be specifically trained to that use case.
Super. Any questions online? Any other questions in the room?
Yeah,
Go ahead.
Zip, this is Jonathan Powell. Has anybody in the Marine Corps UAS community reached out to you guys to explore using this?
Not yet. I would love an introduction to talk to those folks. Yep.
Okay. I'll get your information and maybe I can find somebody who's working the acquisition side of the house and they can talk to you.
Yeah, that'd be great. You know, I know Lee Irwin Perv at PME 266 is working, you know, MUX mail for the Marine Corps, but you know, her focus is really more on the fielding of the airframe and less on the take and the going through the take on the back end. And so the ability to interact with somebody like that would be fantastic. Would love that opportunity.
Yeah, this could be really cool.
Thank you.
All right, so Dip, I want to say thanks again. I appreciate Sheila putting you in touch with us, and look forward to some great things coming out of this. For those in the room, I also want to invite you to continue to look at the NWSI webpage on the NPS main page. You can link to us, just type in NWSI into the search bar. It'll take you to the Seapower Conversations, and then you can be linked to whatever we've got coming up next. So thanks everybody for making time on your lunch to come and join us.
Everyone, thank you for the opportunity to speak with you. It was a pleasure. Have a great day.
Thanks a million, Dip.
Thank you, Rex. Thank you, Sheila.